Hi, in this video we will talk about the series, especially arithmetic series. What actually is the arithmetic series and what is the formula for finding the sum of n terms given in an arithmetic series, and we will see some of the problems that are really interesting and that will helps you to understand actually about the arithmetic series. Next we will see about the geometric series, and similarly we will see the formula for the geometric series to find the sum of n terms, and we will see what condition should be imposed to get the infinite sum of the terms given in a geometric series, and we will see also some solved problems in it. So what is a series? If we have a sequence, let's say that is a sequence whose terms are denoted by an, that means that a1, a2 and a3 and so on to an or maybe more to infinite ones, then the series is actually the sum of these terms. That series is the sum a1 plus a2 plus a3 and plus so on to plus an, and depending how many terms we are taking from the sequence. So here we are taking n terms, and it is denoted by in the formula like this is denoted by I equals to 1 to n ai's, which actually the same expression that is given here. So now we will discuss about the arithmetic series. So similar arithmetic series, in the same way we can define that if we have terms given in a arithmetic sequence, that is the first term is a1, the second term is actually, you know, that the terms are like in this way: a1 plus d, the second term is a2 plus which is actually a1 plus 2d, and so on to, let's say we are taking the nth term, so it will be a1 plus n minus 1 and 2d. So these are the terms given in an AP, and by taking the sum of them is known to be a arithmetic series, and we say this is an Sn, the sum of n terms. So that is Sn will be equals to a1 plus this and plus, and here that so on to plus this one. So these are n terms given in an IP whose sum is Sn we are taking. Now we need to find the formula. What is the formula for Sn? To do that, we can write this whole expression just taking in an opposite way, like that. Firstly we write the last term, that is a1 plus n minus 1 into d. So then we take the another term, which is that previous term, but from this that will be a1 plus n minus 2 into d, right? So here that term was the second term here, that was a1 plus d, but now by taking a writing in an opposite way, then the second term has become a1 plus n minus 2 into d, and similarly that will becomes a1 plus n minus 3 into d, and plus so on. In this way we get in the last, that will be a1, right? So now you can see that if we add the first into the first, we get what? We get 2a1 plus n minus 1 into d, right? So, and moreover, if we add the second to the second, we get the same expression, that a1 plus a1 will be 2a1, and d plus n minus 2 into d will makes it n minus 1 into d. So we get what? So by adding these two expression, we get 2Sn equals to, the first one is same, first one is 2a1 plus n minus 1 into d, and the next one is also 2a1 plus n minus 1 into d, and so on. We get all terms of this form, because this last one also gives 2a1 plus n minus 1 into d. And since all terms are the same one, right? So and adding these same terms time n times, so we can write this whole thing to be n times of 2a1 plus n minus 1 into d. And this is very simple, that as you have seen that if we have a numbers something like 1 is adding n times. So what we write this? We write this as equals to n, because this is n times. So here we also having terms that are the same one and adding n times, so we get n times this. So which implies what? Which it implies, this implies that Sn equals to n by 2 into 2a1 plus n minus 1 into d. Okay, so we have seen that sum of n terms of an AP, which is actually that sum is known as the arithmetic series. Terms of AP is what? This is denoted by Sn, and this is equals to n by 2 into 2a1 plus n minus 1 into d. And as we have seen in the previous video that the nth term of AP is denoted by this one, a1 plus n minus 1 into d. So from here we can see that Sn is actually can be written in the form of n by 2 equals to a1 plus an, right? So these are the formula for the sum of an AP. Okay, so by using these formulas we can get the sum of n terms of an AP. Let's say if I say that we have on the first day of job. So here is a question. On the first day of job we are saying that I am getting a $1, right? And on the next day I get the $2 and so on. Then what would be my salary after the 30 days? Okay, so is it interesting? Yeah, this is interesting. And how we can find this one? So in this case, a1 is what? A1 is actually 1 and d is 2, because that is in so d is 1 here because it is increased by 1. So d is 1 and n is actually 30, because we are interested to find the total salary that is coming in this way, that on the first day of job we are getting $1, on the second day of job we are getting $2, and on the third day we are getting $3, and on the 30th day we are getting $30. So what would be the total salary? So we can use that formula which is the first, which says that it will be as 30. So that will make it 30 over 2 into 2 into 1 plus n minus 1, which is 29, and d is 1, which makes it 15 times that will make it 31. So what is this? 15 times 31 is 15 1 the 15, 5 1 carry 45 1 46. So actually I will get $465 on the end of the month by taking in this way as a salary. So and this helps you to calculate such problems. So we also see some more problems related to this uh, uh, AP, sum of an AP. So here it says that find the sum of all integral multiples of 3 between 4 and 97. So between 4 and 97 we have to find sum we have to find the sum of all integral multiples, that are 3. So first integral multiple of 3 between 4 and 97 will be what? That will be actually 6, right? And the next one will be 9, and so on. It will be continued. But 97, you can see that this is not a multiple of 3. But if we divide 97 by 3, what we actually get? We get 3 3 is the 9, and here that 7 will goes downwards, so that will make 7 3 to the 6, which makes it 1, so which is the remainder. Okay, so if we have the remainder as 1, so it means that 96 will be the largest number in this range, that will be the multiple of 3, so it makes it 96. Okay, so from here what we had this is an AP, and we have to find the sum of this 6 plus 9 plus so on to plus 96, that we had to find. So here we have information that A1 is given, D is given, which is 3, and AN is given, which is 96, and I don't know what is n. So before using this the formula for the Sn, we need to calculate what actually is n. So to find n, we use that formula that we know from the previous lecture, that is an equals to a1 plus n minus 1 into d. So a1 we know, d we know, an we know, so we can find n, this one. So that makes 696 equals to, that is a 6 plus n minus 1, and here that will be 3. So what it gives, so it gives us to uh, that will gives us to 96 equals to 3n plus 3, right? So which makes 96 minus 3 equals to 3n, and from here we can get n equals to what? So n will be equals to 93 over 3, which is equals to 31. So number of terms that are multiples of 3 between 4 and 97 are 31. So what we have to find, we have to find the sum of all these terms. So from it, from the previous slides, you have seen that that Sn was given by n by 2, and that other formula a1 plus an. So an we know, a1 we know, n is known to us, so that makes it 31 by 2 into the 6 plus an is 96, which makes it 31 into, that is 102, and 102 divided by 2, which makes it 51. So this is 51, and the answer will be equals to what? 1581. Okay, you can verify it from the calculator. Okay, so now we go to the next question, which says that find the sum of the 20 terms. That we have to find the term, there are a sum of 20 terms. We have to find whose rth term is 3r plus 1. So actually that is given that ar equals to 3r plus 1, and we have to find a1 plus a2 plus so on to plus a20, right? So first of all, we have to look what actually is a1, what actually is a2, and what actually is a20. So for this, you can see that a1 equals to 3 plus 1, which is 4, and a2 is what? A2 equals to 6 plus 1, which is 7. A3 will be equals to 9 plus 1, which is equals to 10. So from here we can see that this actually the terms are in AP, whose common difference is given, which is 3, and the first term is given and the last term is given. So if you don't want to say, but that's important to know, that we have to be clear about that this the given terms are in AP, otherwise we can't use that formula that we have obtained. So the formula says that Sn equals to n by 2 into a1 plus, so this is that 2a1 plus n minus 1 into d. So here we can use this formula as well. So that makes it s20 we have to find. So it will makes it 10 into 2 times a1, and a1 is 4, so which makes it 8, and 19 times d, which is 19 multiplied by 3. So what it makes, that is a 10 into 8 plus 57, which is equals to actually 650. Just this is just a simplification. 10 times 65, which makes 650. So the sum of 20 terms of the series whose rth term is 3r plus 1 is 650. So now we see that this is another question, which is very interesting. Actually, what it says, that a man repays his loan of 1120 rupees, has taken the 1120 rupees of loan, and he has to repay it, and by paying 15 rupees in the first installment and then increasing the payment by 10% rupees every month, how long will it take to clear all his loan? So what actually is given, that Sn is given because that the total sum of the installments is given, which is the total loan that he has to repay, that is 1120 rupees. So and the other thing that is given, that he is repaying in this way: first month he repays 15 rupees, then other month he pay 25, then to the other month he pay 35, and so on. So what actually we need to find, we need to find n, that how many months it will take to him to repay all his loan. So from the formula we know that is Sn equals to n by 2 into 2a1 plus n minus 1 into d. Okay, so here we know that this a1 we know, d we know, and n we have to find, and Sn we know that, is it? So Sn is what, this is 1120, and n we have to find, and by putting plugging the a1 value, which is 15 here, so 15 plus n minus 1, and d is here, what is this, this is 10. Simply because you can see that in this series each term is has a difference of 10, so this is an arithmetic series actually. That's why we can use this formula. So from here we can get that 1120 equals to n by 2 into 30 plus 10n minus 10, which says that this is equals to, so 2 will cancel out this these terms, so 30 minus 20, 20, 20, which makes, so that will make n into 10 plus 5n. So from here we can say that this is equals to what, this is equals to 5n square plus 10n minus 1120 equals to 0, and we have to solve this. So firstly look that 5 can be taken to common, because that 5 and 1120, if you divide this 1120 by 5 we get 2, which makes it 10, and then this makes 1, and this makes 2 again, which makes 10, and that 20, so 22 24. So from here we get n square plus 2n minus 224 equals to 0. So this is a quadratic equation that we need to solve it. So we can do the midterm breaking in a way that that term is break down into those terms whose product is 224 and the difference is 2. So you can see that 16 and 14, so which makes it 16 4 is 64, 4 6 carry 16 1 6 6 22, so which makes it 224. So from here we can see that this is actually n square plus 16 n minus 14 n minus 224 equals to 0. So we have to solve this uh, equation. So what is actually that was n square plus 16 n minus 14 n minus 224 equals to 0. So by taking n to common, so it will get n plus 16. By taking minus 14 from these two terms, we take common minus 14, so which makes it n plus 16 equals to 0. So so here that is n plus 16, and that is again common, and this is n minus 14 equals to 0. So since we are in the field of real numbers, that in a real numbers any of the two numbers are multiplying and making 0 if and only if any of them is 0. Either this one will be 0 or this one will be 0. So we will see that there are some fields in which that also fields are there, or some rings we say. So in the future videos you will see that it is possible to get the numbers whose multiple is 0 but both are not 0. But here that is we are talking about the real number. So in the real number this is not possible, that they are not 0 non-zero and their product is 0. So that's why either n plus 16 is equals to 0 or n minus 14 equals to 0, which makes it n equals to minus 16 and n equals to 14. So since n is 14, since n is denoting the number of months that he has required to repay all his loan, so it must be a positive, it cannot be negative. So this is not possible in this case, this one. So it means that that number of months he needs to pay is 14. Required number of months, that is n, is 14. Okay, so now we see the next question, and it says that we have a clock, and that clock strikes once when its hour is at 1, and it strikes twice when it is at 2, and it takes the pattern in this way. So how many times does the clock strike in 12 hours? So how many times means that actually we have to calculate all. So in the first it strike 1, and on the 2 it strike 2, and in the 3 it will strike 3, and continuing in this it will strike at 12. So you can see that we have to find this whole sum. So Mm, so if you look into the pattern of the terms, then the terms are in actually in AP, because that it has a form that A1 is 1, D is 1, and N is 12, and AN is also 12. So we use to find the sum formula for an arithmetic series, which is n by 2, and you can here use that a1 plus an, because you know that an here, so it makes a simple calculation. So n is 12, so that makes 6 into 1 plus 12, which is 13. So 13 times 6 is 78. So it will strike 78 times when the clock will be at 12 hours. So every time he is striking twice, thrice, and so on. So it will strike 78 times. Okay. So now we talk about the geometric series. So what actually is the geometric series? So as we have seen that for the arithmetic series, the terms are in arithmetic progressions, whose sum is an arithmetic series. So if the terms are like this terms a1, a2, and so on, an, so from the start we are talking about the n terms are in GP, and you know that what is a GP from the previous video. So you can look that link into the comment description as well. So if we have in these terms in GP, then the sum of them is also sum of them is known to be a geometric series. So and we have to find this sum. So actually by definition of the nth term, that we know that the nth term of a GP is what, that is an equals to a1 r raised to power n minus 1, makes it this, that will be a1 plus a1 r plus so on plus a1 r raised to power n minus 1, and that from here that we can see that this is equals to a1 into 1 plus r squared plus so on plus r raised to power n minus 1. So if we multiply this whole thing by 1 minus r, and then we get what, we get a1 into 1 minus r into 1 plus r square plus so on plus r raised to power n minus 1. Okay, so here that is multiplying these two terms, and in this there are two terms. So firstly one will multiply with this whole thing, and then r will multiply with this whole thing. Okay, So by doing this, and a1 will be in outside, and in the bracket we write this. So when one is multiplying, so we get the same 1 plus r square plus so on plus r raised to power n minus 1, and this is a minus, and that will gives what, that will be r minus r square minus r cube, and so on, minus r raised to power n minus 1 minus r raised to power n. Okay, so that comes from the previous term, that is r raised to power n minus 2, and when n r multiply, then we get r raised to power n minus 1. Okay, so you can see that 1 cannot cancel out with any of the term, but r is cancelled with r square is cancelled with r square, and r cube is cancelled with r cube, and so on. R n raised to power n minus 1 is cancelled by r raised to power n minus 1. So all these terms will be cancelled out by the additing inverse of each other. So we only left with 1 and r raised to power n with negative sign. So it makes it a1 into 1 minus r raised to power n. So thus what we had, so from here we had Sn equals to a1 into 1 minus r raised to power n over 1 minus r, and here r is less than 1. Okay, because that is 1 minus r. So if r is r mod, actually we have to say this r mod is less than 1. So if r mod is greater than 1, then Sn will be equals to what, that will be a1, and that r raised to power n minus 1 over r minus 1, and for r mod greater than 1. Now we talk about that r raised to power n, that, and if n is increasing, then what would be the value of rn? Either it will be increasing or decreasing. Like so, if you see that if we take r equals to 2, then each increasing power will increase the value. Like that, r square will be equals to 4 and r cube equals to 8. And you can see that as n is increasing, then the power value of the power is also increasing. But if r is half, then what is happening? Then in this case, that we get to r square is 1 by 4, r cube is 1 by 8, and so on. And you know that as the denominator is increasing, then the overall value is decreasing. So it means that if r mod is less than 1, then by increasing power of n will decrease the whole value, and it will decrease. And if n is bigger and bigger and bigger, means that if n is tending to infinity, then the whole thing will tend to 0. So from here, and as we know that for all mod less than 1, we have the formula for n terms was n into 1 minus r raised to power n over 1 minus r. And from here we have seen that if r mod is less than 1, then the whole this term tends to 0. This term tends to 0 when n is increasing. Okay, so if so from here we can see that s infinity is actually, so it was here a1, so it will be a1 over 1 minus r, provided, so this is important that if r mod is not less than 1, then we can't find the sum of the series of infinite terms. So by keeping in mind these formulas, we will solve the few of the problems related to it. So here is a first problem which says that find the fractions equivalent to the recurring decimal. So this is a recurring decimal, and we have to find the fraction that will be equivalent to this whole decimal. And actually, what does mean by this? This is here one, and this dot shows that these values are repeating. Recurring means that a repeated decimal. So it will be like 1.34343434 and so on. So So if we look into this, then it will be 1 plus 0.343434 and so on. So I can write this 1 plus 34 over 100 plus 34 over 10 raised to power 4 plus so on. Are you confused here? So let me explain it more. So it is actually is 1 plus 0.34 plus 0.0034 plus so on, right? So from here we can see that this is actually meant. So next term will be 34 over 10 raised to power 6 plus so on. So infinite term. So we can write this whole thing to be equals to 1 plus 34 over 100 is common. So here will be 1 plus 1 over 100 or 1 10 raised to power 2 plus 1 over 10 raised to power 4 plus so on. So what is this actually? In the bracket, this is a geometric series and with the common ratio r equals to 1 over 100, right? And a1 is 1. So and this is an infinite series and r mod is less than 1, so we can use that formula which says that it will be equal to a1 over 1 minus r. So from here that will be equals to 1 plus 34 over 100 into bracket that will be equals to a1 which is 1 over 1 minus r which is 1 over 100, so which makes it equals to 1 plus 34 over 100 into 1 minus 1 over 100 makes it 99 over 100, and 99 over 100, so 100 over 99 we can write this, which makes it what? Which makes it 1 plus 34 over 99, which is equals to actually 133 over 99. So from here we have seen that that's 1.34343434 by using that infinite sum series we get this fraction. Okay, so here is an other question that says that if we have a ball, that is a ball, and that is a dropped from a height of 27 meters. So when it has been dropped, then it has covered the 27 meter and it strikes the that surface of earth. So this is a surface of earth here. So it strikes and it rebounds back, and it rebounds two-thirds of the distance it falls. So it has fallen by a distance of 27 meters, so it will rebound two-thirds of 27, which means that 2 by 3 times 27. So if it is rebound, then it will come back as well. So in that distance will it travel before coming to rest. So in this way it continues to rebounds, and how much distance it will cover to before coming to rest. So first of all we have to look what actually it is covering the distance. So on the first, that is has a distance 27, then on the next that has a distance 2 by 3 into 27 and coming back to that, so which makes it 2 into this 2 by 3 into 27, and the next one again 2 by 3 times of this, which makes it 2 by 3 square times 27, and again that will be a 2 and plus so on. So here most of the students think that this is a geometric series. Yeah, this is geometric series, but to find the sum, infinite sum, we have to make this in the form that the combination must be less than 1. So we can see that this 27 will be as it is, and that we can take from these all these terms, we can take common 2 into what, 2 by 3 into 227. That's the whole thing will be common in that. Then in the bracket we will get what we get 1 plus 2 by 3, because that was a 2 by 3 scale, so 1 2 by 3 is coming outside, so we will left with 1 2 by 3, and 2 and 27 will be out. So here as well 2 by 3 square plus so on. Though this is an infinite series with a1 equals to 1 and r equals to 2 by 3, which is less than 1. So here we can use the formula for finding the infinite sum of the geometric series with common ratio less than 1. So it makes it equals to 27 plus, that is 4 by so 3 9 is 27, so 4 9 is 4 times 9, and into bracket, that is a1 is 1 and 1 minus r, which is 2 by 3. Any confusion up to now? So I think so no. So if you have, so you can put the confusion into the comment box, so definitely I will answer you. So 3 minus 2 is 1 by 3, and that 1 over 1 by 3 makes it 3. So we get what? We get 27 plus 4 times 27, which is equals to 27 times 5. So which is equals to 5 sevens the 35, 3 carry 5 to the 10 and 3 135 meter. So it will cover a distance of 130 meter, 5 meters before coming to the rest. So here is another question that says that sum of an infinite geometric series is 9 and the sum of the square of its terms is 81 by 5. Find the series. We have to find the series. So, first of all, that this is an infinite geometric series, right? So from here I got an idea that if he is talking about the sum of infinite geometry series, then r will be less than 1. So that's before r mod means maybe that will be negative, so our absolute value of the r will be less than 1. So it says that s infinity is 9 given, and by formula that will be equals to a1 over 1 minus r, which will make it 9. Okay, the next thing is that we have that was a geometry series whose first term was a1, the common ratio was r we have taken, right? And that we have considered this geometry series whose infinite sum is 9. So from here we have got this expression. Now the next one is that the sum of the squares of its terms. So by taking the squares of these terms and then taking the sum, then it is given by this. So first of all we take the squares, so we get to the series, that is a1 square plus a1 square r square plus a1 square r4 plus so on. And if I call this a sum to be s infinity square, then it will be equals to what? S infinity square will be equals to 81 over 5. So here I have put it just to make sure that we are taking this series. So here the first term is what? This is a1 square, and the common ratio is r square, so it will make 1 minus r square equals to 81 over 5. And it this expression is actually can be written as a1 over 1 minus r into a1 over 1 plus r, which is equals to 81 over 5. So you know that this a1 over 1 minus r is what? This is 9 here. So we can plug this thing here, so which makes this whole equation to be equals to a1 over 1 plus r, and that dividing on the both sides, so makes it 9 over 5, right? So this is another equation. Let's say this is an 2 equation number 2. So here this was equation number 1, and we have to solve them to find a1 and r, so we can get this series. So here we solve it. So from the first one we get a1 equals to 9 into 1 minus r, and substituting this into the second, so we get 9 into 1 minus r over 1 plus r equals to what? This is 9 over 5, which makes it equals to 1 minus r over 1 plus r equals to 1 over 5, which is 1 plus r equals to 5 minus 5r, right? So it makes it r equals to, so 4 over 6, which is less than 1. That was unexpected. So as we are now known to be r, so we can put this in any of the equation to get a1. So a1 will be equals to 9 into 1 minus 4 over 6, right? So which makes it 9 into 9 into 6 minus 4, which will make it 2 over 6, which is 1 over 3, which makes it 3. So that first term is 3 with the common ratio 4 by 6, which can be written as well 2 by 3. So thus from here we conclude that required series is what? So required series in this case will become equals to 3, and next one 3 plus the next term will become 3 into 2 by 3 with plus next term will be 3 into 2 by 3 squared plus so on. So this is a required geometric series which gives satisfies this condition that its infinite sum is 9, and its if we take the squares of each of its terms, then the sum of the squares of each of its terms will be equals to 81 by 5. So it will satisfy. So here is another question, and it says that we have a population of a big town, which is given 9,72,405 at the present, and 4 years before it was 8 lakh. Find its rate of increase if it increased geometrically. So actually, it says that initially it was 800,000, and then if we say that it is increased by a rate of p, that p is a rate of increase, or someone say, okay, if you don't like this p, so I can put this p to be equals to r. So if the rate of increase is r, this is an assumption, then on the first year, and after the first year it will becomes 800,000 plus 800,000 times r over 100, because that is a percentage, so that's why we have to divide by 100, so which makes it 8,000, 800,000 and 1 plus r over 100. So we have to find this r. So next 83 will be equals to 8,000, 800,000 into 1 plus r over 100 whole square. So what actually is given to us? That is given to us if we have taken this as a sequence whose term is this one, and after the 1 year actually that is the second term, and after the 2 year that is the third term. So actually this is a fifth term of this sequence. So eventually a5 is given to us 972,405. So which makes it what that makes 800,000 into 1 plus r over 100 raised to power 4 equals to 972,405, and if you solve this equation you will get r equals to 5%. So from here we can conclude that this population is increasing by a 5%.